This is Dr. Obulakonda Reddy, Department of Cybersecurity, CSC Cybersecurity. Today we will discuss on resource management and scheduling, short form read as a RMS. In high performance computing, how the RMS will works, resource management and scheduling. The resource management scheduling is the distributing applications among computers to maximize their throughput. So it has to be distributing applications among computers. So in between the systems, it has to be distribute the different applications. Like it has to be, for example, we have in a cluster system. It has to be distributed applications to different systems, like one system to other systems, like this. So distributing applications among computers to maximize their throughput. Throughput means per seconds. For seconds, how many tasks are completed. The throughput will tell that how many jobs are completed for a particular amount of time. So, for example, first system, how many tasks are completed. So that is maximize. So finally, it has to be maximize the throughput. That is the duty of a RMS, the remote resource management and scheduling. That has to be a distributing applications among computers to maximize their throughput. Now see here, it has to be enable the effective and efficient utilization of the resources available. Whatever the resources are existed in a cluster environment, that has to be effectively and efficient utilization of all resources. Then RMS, what are the software components are required? In the software components, this is the one of thing. Software components are resource manager, resource scheduler. So resource manager. The resource manager, the duty is allocating, locating and allotment. Allocating computational resources and their authentication and process creation and migration. These are all roles we'll see in resource manager. The resource manager will have monitor with all like computational resources, allotting and locating where it has to be allocated and allotment, computational resource, authentication, processes creation and migration. These are all activity done in resource management. What is a resource scheduler? So they have to schedule like queuing applications. They are scheduling with what are the applications is getting in a systems that has to be in a queue. What are the first applications like everything it has to maintain in a queue. Queuing applications, resource location and assignment. Resource location where the resource has to be located and assignment. So particular resource jobs. So now for example, we want to require for a particular resources that has to be assigned to a particular process. So these are discussed with a software component. Software components as resource manager and resource scheduler. Resource means the manager that has to be allotted, managing all the resources. And then scheduler, they have to schedule like queuing applications. What are the applications getting in the for doing of processes? They have to be kept into a queue. Queuing and resource allocating assignments. So which is free, that has to be allotted to a processes. So this is software components which has to be used in RMS, resource management and scheduling. Now, what are the regions using RMS? What are the regions to use for RMS? Now, see first one, provide an increased and reliability. So it has to be provide an increased reliable throughput of user applications on the systems. So throughput, reliable and increase the provide and it has to be performance has to be increased. Reliable, it has to be a very reliable system. And throughput. So for user applications on the systems. Load balancing. This is a very important thing. The balancing, it has to be balancing the load. So different systems, we have to get not to give an heavy load to a particular system. It has to be load balancing. It has to be distributing the different systems. And utilizing spare CPU cycles. So this is the one thing, regions. Regions go for RMS. Regions to use for RMS. Utilization, spare CPU cycles. Next, providing fault tolerant system. This system has to be failed. So we have to identify and then fault tolerant systems has to be identified and then rectify the problems. Manage access to powerful systems. So these are all the reasons we have used for RMS, Resource Management System. So the basic architecture of RMS is a client server system. Client has a raise a request, then the server has to be a process that request. So the basic architecture of RMS is a client server system. What are the services provided by the RMS? One is a process migration. First one is a process migration. One process has to be migrated with a other systems, other system processes. One task. Computational resource has become too heavily loaded, and fault tolerant concern. So these are the 2 points we have to go for process migrations. Checkpointing. Second, checkpointing. So this is the thing. And scavenging idle cycles. This is the workstations are almost 70 to 90% of the time most workstations are idle. 70 to 90% of the cycles. And the fault tolerance. You have to identify the fault tolerance. Whichever the system it has to be a fault, we have to identify, then rectify that systems. And the minimization of impact on users. Minimization of impact on users. And load balancing. Previously we discussed that one. The balancing load equally to different systems. And multiple application queues. They have to maintain with a multiple application queues. Whatever the applications we have to run on a different systems, that has to be maintained with a queue, multiple application queues. So these are all the services provided by the RM. Some popular resources management systems like LSF. This is a resource for commercial systems with the URL, Unified Resource Locators. LSF system. This is the some popular resources management system, RMS. So now LSF. So this is a resource, and Codyne. So this is a resource for this one, Codyne. And then EasyLL. So this is the NQU. This is a resource of that one. Then public domain URLs are Condor. So this is the Condor CS www.cs.wisc.edu/Condor. So this is public domain URL systems. GNQS. So this is the URL. DQS and the PRM. Next PBS. These are all the different public domain URLs and commercial systems URLs for providing as RMS. Next, we'll see different programming environment and tools under the RMS. Programming environment and tools. First thing we have discussed with the threads. The thread is a lightweight process that has to be executed in operating systems. So that the process has to be executed with a threads. The threads have to be executed with a personal computer, symmetric multiprocessor systems. Now, networking of workstations. Now is the network of workstations. So threads are executed to these are systems. Next, in thread we will consider with the multiprocessor systems. Multiprocessor, multiprocessor. The name itself suggested with the group of processor has to be maintained. So that is called multiprocessor systems. So now here used to simultaneously utilize all the processors. So whatever we have to combine with the processors, that multiprocessor systems used effectively utilize the all available processors. So that is comes under multiprocessor systems. For this one, we have go for threads. Uniprocessor systems, only single processor. Multi instance, a group of processor has to be combined into a one processor. Like these are all combined into a one processor. This is called multiprocessor. Then uniprocessor instance, only a single processor. Okay. Used to utilize the system resources effectively. Whatever the systems we have to run, that system resources effectively utilize. Threading for multiprocessor systems and threading for uniprocessor systems, only a single processor. That is also in case if you use threads or uniprocessor system, that is to utilize system resources effectively. What are the systems? A single system and the resources, we have to utilize that resources effectively. And the multi-threaded applications that does provide offers for quicker response multi-threaded applications. In case if you go for multi-threaded, that has to be a quicker response to the user input and the programs are run faster. It is the potentially portable. The threads are potentially portable as their exit and IEEE standards, or POSIX, Portable Operating System Interface. So threads interface. So it has the POSIX. POSIX is the one of the interface that has to be used with the portability and compatibility in between the operating systems, which has to be used Unix and Unix-like systems. That is the interfaces. POSIX is one of the interface, portable operating system interface, that has to be run with a P threads, portability threads. Now, extensively used in developing both application and system softwares. So that has to be used extensively developing both either application and the system softwares. So this is the programming environment and tools. First case we have to discuss with a threads. And second thing, programming environment and tools. Second thing, we discuss with a message passing systems like MPI, PVM. So message passing systems, MPS. Like allow, which has to be MPS, which has to be allow FSEN parallel program to be written for distributed memory systems. For distributed memory systems, effectively and FSEN parallel programs to written for a distributed memory systems. It has to be two types, that is PVM and MPI. What is the PVM here? It has to be supported both environment and message passing library. It has to be PVM has to be supported both environment as well as the message passing library. MPI, message passing specifications, design the standard for distributed memory parallel computing using explicit message passing. And it has to be established a practical, portable. It has to be attempt to establish a practical, portable, efficient, flexible standard messaging. So this has been created with a message, practical, establish a practical, portable, efficient and flexible standard for message passing. And next thing is, it has to be generally allocation developer for MPI, as it's fast becoming de facto standard for message passing. So this is used for programming environment tools in second. And third thing, you see the third, DMS, distributed shared memory systems, DMS. Under DMS, distributed sharing memory, message passing, shared memory systems, DSM on a distributed memory systems. Again, we'll see this one like alternative cost effective solution, software DSM, hardware DSM. Now see message passing. The message has to be communicated with a one system to other. Here, the most message passing is the most efficient, widely used programming paradigm and distributed memory systems. In DMS, the message passing is a most efficiently, widely used programming paradigm, and it is very complex and difficult to write a program. Now, coming to the shared memory systems, offer a simple and general programming model, which has to provide with a very simple and general programming, shared memory, but suffer from scalability. It does not support it with the increase of a systems, but suffer from scalability. If I want to increase it from 100 system to 1000 system, shared memory has not to be supported. DSM, distributed shared memory and distributed memory system. So it has to be alternative. It is to be alternative for cost effective solution. Distributed shared memory. In a shared memory system that has a scalability is the problem. That's why we go for DSM. Distributed shared memory and distributed memory systems. It is an alternative cost effective solution. So next, under this one, we discuss with the software DSM and hardware DSM. Software DSM is usually built as a separate layer on top of the communication interface. It has to be a separate layer on the top of the communication interface. The full advantage of this application characteristics. This is application characteristics like we are creating with it virtual pages, objects, language types are units of sharing. And it has to be other thing is a thread marks and lambda. Now, hardware DSMs. Hardware DSM are better performance, no burden on users, but it is used as a better performance, but no burden on user and software layers. It is a fine granular of sharing. It is a good for sharing. Extension of the cache coherence scheme. It is an extension like hardware is the cache coherence scheme. Extension for a cache coherence scheme. And increase hardware complexity. It has to be increased hardware complexity. The examples are DASS, Merlin. So this is the third level of programming environment and tools. DSM is the third level. DSM systems are third. And the fourth level is the parallel debuggers and profilers. So fourth level we'll discuss with parallel debuggers. Bug means errors. Debugger means correcting the errors. Parallel debuggers and profilers. Debuggers. So debuggers are very limited. And it has to be used with HPDF. What is the full form of this? High performance debugging for. Short form we write as a HPDF. High performance debugging for. It has to be used as a parallel tool, which is under a consortium project consortium project in 1996. It has to be a parallel tool. HPDF is a parallel tools consortium project in 1996. Now developed on HPD, high performance debugging version specifications. This HPD has which define the functionality, semantics, and syntax for commercial line parallel debugger. What is the total view of a parallel debugger and profilers? The view of parallel debuggers and profilers. A commercial product from Dolphin Interconnect Solutions. It is a commercial product from Dolphin Interconnect Solutions. Only wide available GUI graphical user interface based parallel debugger that support multiple HPC platforms, high performance computing platforms. And it is only used for homogeneous same environments. Only used in same environment, where each process of the parallel application being debugged must be running under the same version of the operating system. It has to be a homogeneous environment. Only used for a homogeneous environment. What is the functionality of parallel debuggers? What is the functionality? Functionality of a parallel debuggers. Now, managing multiple processes, which has to be managed with multiple processes and multiple thread within a processes. Within a processes, it has to be managed with multiple processes and multiple threads. That is the first functionality of a parallel debuggers. Second functionality is each process its own window. Each process which has to maintain its own window. And third one, it's displaying the source code, stack trace, which is having in a track, and the stack frame, everything which has to framing in a stack form, first in first out, for one or more processes. For maintain, these are all maintained in one or more process, displaying source code, stack track, stack frame, stack trace, and it has to be maintained with a diving into objects, subroutines, and functions. It has to be setting with both source level and mission level breakpoints. Source level and mission level breakpoints. From source point at the end of the system, at the end mission level also we have to setting with a breakpoint. And sharing breakpoints between groups of processes. First group, what is the breakpoint of that? Second group, third. It has to be maintained with a breakpoint in between the group of processes. Sharing breakpoints between group of processes. Defining watch and evaluation points, which has to be other functionality is the defining watch and evaluation points. And next thing is displaying arrays and its slices. And which has to be it has to be managed with the variables and constants also. Manipulating and manage the code variables and constants. So these are all the major functionality of a parallel debuggers. Next level we'll see here programming environment and tools. Fifth stage we'll see performance analysis tools. Performance. We have to execute a different programming here. What is the performance? What is the performance of that particular thing? Then performance used for this performance analysis, we go for a tool. Some use for some tools that has to be analyzed or performance has to be evaluated. Now see here, help programmer to understand the performance characteristics of an application. So application, what is the corresponding performance? What is the application performance? Help programmer to understand the performance characteristics of an application and analyze, locate parts of an application that exhibit poor performance and create program bottlenecks. What are the major components? So now observe that what are the major components? The major components is inserting instrumentation calls to the performance, monitoring routines into the user applications. In user application, that has to be we have to insert it with a instrumentation calls. This is the thing. So major components. So what are the instrumentation calls that has to be inserted into application to the performance monitoring routing into the user applications. And second thing is runtime performance library that consists of a set of monitoring routines, monitoring routine works, runtime performance library. And we have used different set of tools for processing and displaying the performance data. So these are all the major components. And then what are the issue with performance monitoring tools? What are the issues? Intrusiveness of the tracing calls. So for the calls instrumentation, we have to insert instrumentation calls to their performance monitoring routines into the user applications. Tracing calls, it is the intrusiveness of the tracing calls and their impact on the application performance. So this is the one of the issue in the performance. And then instrumentation affects the performance characteristics of the parallel applications and provide false view of its performance behavior. So these are all the two issues. Now here performance analysis and visualization tools. This is the list out here. One table I have done. What is the tool? AMS. First tool is AMS, which supported for instrumentation, monitoring, library, and analysis. This is a URL address. This is the address for AMS, which is supported for instrumentation calls, monitoring routine activities, library analysis, monitoring library and analysis. MP is the one of the two which has to be supported with a logging library, snapshot, performance visualization. So this is the address for URL address for that unified resource location. And then third one is the Pablo. So Pablo, then monitoring library and analysis. So this is the location, URL location. And Paradigm, PARADYM. So now which has to be supported with a dynamic instrumentation running analysis. So URL address for this. SV Pablo. Another tool is the SV Pablo, which are supported with a integrated instrumenter, monitoring library and analysis. Their URL address, corresponding URL address for this. Next thing is VAM PIR. So which has to be monitoring library, performance visualization. For these two things, we have to go for VAM PIR. So this is the URL location. DIMENMAS, diamonds. So which has to be supported with performance prediction for message passing paradigms and their corresponding URL location. Paradigm, program visualization and analysis. And this is the uniform resource like HTTP www.cptva.upc.es.paradigm. So these are all the different performance analysis tools and visualization tools. This table will be helpful for corresponding URL address for a particular tools. and which tool supporting for this tool, they supporting and the URL locations. Tool supported for what, and then corresponding URL address. This is mostly used for high performance control. Now, in the sixth level, we observed in sixth level programming environment and tools. In the sixth level, cluster administration tools. The cluster administrator tools, Berkeley now. So, what is the full form of now? Now is the network of workstations. A group of workstations we are connected under this now. Now is the network of workstations. Berkeley now. So, Berkeley is a scientist. He has to be forming with a group of workstations. So, Berkeley now systems gather and store data in a relational databases. Berkeley systems, Berkeley now system, Berkeley now workstations has to be collected with gather, store data in a relational databases. And Java applet. So use Java applet to allow users to monitor a system. So monitoring purpose, we have to use Java applet. The users use Java applet to monitor a system. Next thing is cluster administration tools. SMILE, SMILE. What is a SMILE full form? Scalable multi-computer implementation using low-cost equipment. That's simply short form write as a SMILE. So it is also called as a KCAP. KCAP. Simply short form write as a KCAP. So which has to be consist of compute nodes, whatever the processing ready to do that it has to be maintained, and a management node. All system which has to be maintained one node, management node, and a client that can control and monitor a cluster. A client has to be that can control and monitor the cluster through a KMAP or SMILE. Then KMAP uses Java applet, which is also used Java applet to connect the management node through the predefined URL address in the clusters. KMAP uses Java applet to connect the management node with help of a predefined URL address in the clusters. And the third is the cluster administration tool is the Parma. It is a compressive environment for monitoring large clusters. It is one of the good environment for monitoring large clusters. Parma, PRMA. And use client server techniques to provide transparent access to all nodes to be monitored. It provide transparent access to all nodes to be monitored. Client server techniques. And the Paraman server, and we have maintained in this technique, it has to be maintained with the Paraman server as well as the Paraman client also. Both sides, it has to, server side has to maintain Paraman, and the client side also maintained with the Paraman. Both sides we have maintained with the Paraman. These are all the cluster administration tools. Berkeley now, SMILE. SMILE is also called as the KMAP and the Paraman. Now, this is the reference I take from here. High performance cluster computing, architecture and systems, right? Here. Now I was collecting information from this test. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.